George Parks.
And I'm Malika Kulkarni.
And today we're going to be showing you our project, the Laboratory Management Asset Organizer.
So why our project? Like all the labs at GTRI, the Electro-Optical Systems Lab has a lot of expensive equipment that we need to account for. Whenever anybody takes this technology out, checks it out of the lab, and checks it back in, we always have to know where it is so people can effectively and efficiently conduct their research. And that's why we made this system.
So in order to develop this system, we developed two components. First of all, we have a desktop server, and that's a Windows PC that runs our server application along with our PostgreSQL database for data persistency. This is connected to the GTRI local internet and connected to the Pi via Ethernet. Our thin client, or connected to our thin client via Ethernet. Our thin client is a Raspberry Pi 3B that runs the client application. That client application manages communications with the server and also communicates with the barcode scanner and the RFID reader via USB serial. An important concern while developing this project was the security. So we made sure to work with the GTRI CSG, cybersecurity, to ensure that the software does not pose a risk to the GTRI internal network. And this influenced a lot of the design decisions when we were designing our system. For instance, the Pi does not have internet access. It exclusively communicates via a physical link to the desktop computer, which is approved by CSG to operate on the GTRI network. This is why we ended up choosing a computer over a virtual machine or another hosting solution that may be more robust, because it's easier to directly link the Pi into the, which is not approved to run in the network, to the computer, which is. Another potential benefit of our system is by using a client-server model, multiple clients can be connected to our one server at any given time, which means that if in the future you want to potentially expand the system, you could simply spin up more client devices to allow people to check in and out their items and connect them, just point them towards the server running on the computer, and that would allow for instant scaling of the system and overall expanded reach.
So here is our system booting up. On the left, there's an RFID reader for GT badges, the Pi display itself, and a barcode scanner. So when entering the lab, the first thing a researcher would do is take their GT badge and scan the RFID reader. Since our database is not already populated with everyone's GT badge number and their name, our system first takes you to a screen where you can input your name and email so that the next time you go through this process, you never have to type anything in, and our system already knows who you are. After you click continue, you'll be led to a home screen where you can either check out an item from the lab, return the item from the lab, or view everything that you have checked out. When you go to check out an item, every single piece of equipment in the lab that we worked in already has a QR code or barcode that's associated with the piece of technology that it's on. If you scan the barcode, it leads you to a page where it shows you all the items that you scanned. You can scan an unlimited amount of items. After you click continue, it shows you all the items that you've successfully checked out and now can take for your research. And it also shows you the items with errors. These errors would only occur if someone has already checked out this item and maybe has left it lying around. This is really just for the efficacy of the program, just to make sure that you're not stealing someone else's item when it's in use. You can just always go up to them in the lab and ask if you can borrow the item. After you go back, returning items works the exact same way in which you scan the QR code. And the great thing is that even if you're not the one who has checked out the item, you can return it. This also really helps with the efficiency of our system, because I know researchers are super busy and can't always return the item themselves. The last feature of this, main feature of the system, is that you can see all the items that you've checked out. Obviously, not everyone's going to have just one piece of technology checked out, so it becomes a scrollable view so you can see everything, so you yourself can keep yourself accountable. And that is our system being used successfully.
So in order to develop this application, we built a client application. This is what runs on the Pi, and it's built in Python using the GTRI framework. And there's a couple things that we did to make sure that the user experience was smooth and easy to use. For instance, when we were developing our system, we had an interesting problem where we needed to develop a page router. If anyone is familiar with React and the React router, or maybe even in the browser where you navigate from page to page by going to like /index or a folder or something on a website, this system does not exist in Qt. So we had to develop one from scratch. So basically, we modeled it after the one in the browser, where you have paths, and those paths are associated with pages, and the pages can take components and properties as you move between them. And that has made moving throughout the application significantly easier. Another interesting problem we had is managing state throughout the application. Basically, state is information that the program needs while it's running, like data, like maybe your name or your badge number or items that you've checked out. Qt also does not have a state system, so we had to implement that from scratch. So we took after a library called React Redux, which manages state, and tried to make a global state store, which is basically just a state that the entire application can access at all times. So that stores things like the user's name and other data about the user while they're navigating the application. Another important thing we did in our client application was using threading. And we really use this in two main ways. So basically, threading is where you can run multiple processes concurrently on the same computer at the same time. So we use this for things that are either long-lasting or blocking. Blocking is something that would pause the execution of the program, essentially freezing it while it waits for some kind of response or something to happen. So we use this in two ways. One, connecting to our peripheral devices, like our scanner or our barcode reader. These run over USB serial, and USB serial usually requires that someone sit at the other end of the serial connection and listen in on what's coming through, and then interpret it, however, and then do actions on the data. This can take a few milliseconds per each call, but does stack up and make the program feel super unresponsive. So we split this off into another thread entirely. That thread handles serial communication and will check the serial ports while the primary application is running. And if something is to happen, like someone scans the badge or scans the barcode, it will send a message back to the main program, allowing the main program to handle processing. Another important thing we used threading for was network requests. Because we use a client-server model, there's a lot of communication between the Raspberry Pi client and the desktop server that handles all of the actual checkout information. So these responses can take anywhere as low as 200 milliseconds, but up to 2 seconds. And during this time, the entire program is stopped while it waits for a response from the server. This is horrible because when you press on things, it doesn't work. There's no response, there's no feedback, it looks like it's crashing. So we split this off into its own thread as well. A thread will be created to make a network request, and then it will wait for that response and then send it back to the main application whenever a response is received. And this has the added benefit of letting us show a loading screen, like the progress bar, while it's loading, which shows the user that something is happening and the program has not broken. Another important component of this system is the use of reusable components to put everything together. And this is basically the idea that in all three of our main screens is essentially a title, a list, and 2 action buttons. So instead of copying and pasting this over and over again, we actually developed one primary component, which we then inherit from all of the other components. So that component exposes things like a function to make a list and a function to make buttons. So when you're developing, you can just create another subclass of that class and inherit all of its characteristics and quickly make new things. This makes things much faster to develop since you don't actually have to recode it every single time. It also makes it much more manageable because when there's bugs, you can just change the main code and it'll change for all of the state inheriting subcomponents. This was a huge help in development. Another thing we made sure to do is lots of pre-configured scripts in VS Code for testing. In order to explore sort of weird edge cases, we made sure to have lots of scripts to make testing really quick and efficient. For instance, we can spin up the client application on the computer, we can spin it up automatically on the Pi over SSH, we can add data to the database, and all sorts of other quick test functions that are necessary to quickly test things. Instead of spending all your time making weird edge cases so you can see what happens, we can spend less time making the edge cases and more time testing and fixing them. That hugely sped up development. Another important characteristic of our application is the admin panel. Now, this is exposed from the server as a web application that you can get to while you're connected to the GTRI internet. There's a couple important things that you can manage in here. For instance, there are API keys. API keys are like passwords. You use them to secure the connection and describe what client is connecting to a server or what user is connecting to the admin panel. And these are things that you can control directly inside the admin panel. You can add new ones and then copy them, seed them, and add them to your application so that they can talk to the server securely. Another thing that you can manage are checkouts, and this is what we call a transaction where users are taking out items. So you can see when a checkout started, what they checked out, the barcodes of the thing they checked out, their username, their GTID, and a whole host of other information. This is all readily available to anyone with access to the admin panel.
Another really important feature of the admin panel is seeing all the list of the items that are in the laboratory in the database. You can full text search all the items by their barcode, the name, and the description, which includes the make and model of these pieces of technology in the laboratory we were working in. What was a really finicky type of problem that we had to deal with was that when using Flask Admin to make the admin panel, there was no way to have users be able to add images from files on their computer in an easy format. So we had to implement custom form support for these images. And as you can see on the right, it's super easy to create a new item because obviously it's important that after we leave, as new, more expensive technologies get added to the lab, we can keep adding those items into our database for the system to be successful.
Another very important characteristic of our program is the documentation. In order to make sure that this system is used far into the future, everything is very documented. There's comments in our code and there are readmes throughout the application with instructions on the first-time setup, the admin panel use, and regular use of the system. And this should drastically increase the longevity of the system because people should be able to use and also expand it far into the future for when new requirements may be necessary, even after we have left. And that's about it. Any questions?
If you had some more time to work in the system, what would be the next feature you might consider adding?
Next features would definitely be a more streamlined way to add an item from on the client device, since it's a little annoying to have to jump back to the desktop device. And also more integrated support for calibration dates. This was something we sort of touched on very briefly. In the lab, there's a lot of equipment that is being calibrated at any given time, and it's necessary that it stays up to date on this calibration, or else the equipment might not give valuable results. It would be better, we have a little bit of support for that just with, oh, the calibration period is up, it's time to calibrate it again. It would be better if you could modify that, see that, and more information about that actually in the UI. One more thing that we would probably add is an easier way to authenticate to the admin panel, and potentially integration into the actual GT Buzzcard database, so that you wouldn't have to complete that first time setup every single time. It would just go to you automatically. But that was prohibitively difficult to do because we have to get everything approved by the technology department. So
Yeah, exactly. Because we were on this local device, we couldn't exactly also figure out how to Gmail users after maybe they've been checked out and the system hasn't returned it. So that's definitely a feature that would be really cool to use.
Any other questions? What's your greatest lesson learned from this experience?
Well, I came into this with no hardware experience. I had never used a Pi display or anything like that. I'm stuck very strictly to software. So I think definitely being able to use hardware in the lab was the best experience.
I would say the one thing is whatever debugging time you think you need, double it. That's what I learned, because we had some of the most obnoxious bugs. For instance, we had this scanner, so we ended up having to purchase another scanner because our original scanner actually used a very poorly documented, sort of a lower grade Chinese chipset that doesn't strictly interface very correctly with the Linux kernel that we were using. So we had to do all sorts of crazy debugging steps, like upgrading the kernel